if we look at this phase change diagram, this is a time. In other words, we're adding energy to it as time goes on and the temperature increases. Now I could reverse time. If I do that, that means I'm removing energy. So make sure that we know what states these are. So if we're looking at water, for example, ice, this is what state?
Solid.
Obviously, solid, liquid, and a gas. Now my question is, why are there two plateaus here? Here and here. They've actually been butchered, but there's two plateaus there. Kind of. What is not changing as it undergoes a phase change? Temperature. Temperature remains the same. In other words, if we're under normal atmospheric conditions, in other words, what we're experiencing right now, it's a nice sunny day outside, water freezes at what temperature? 0. And it boils at 100. Okay, so those are our normal conditions. However, I cannot have solid water under normal conditions at a temperature of 1 degree Celsius and have it be a liquid, okay, under normal conditions. So what's happening here, that solid has to undergo a complete phase change before the temperature starts to change again. Again, this is theoretical, because if I look, this is probably a little easier to look at, what phase is the water at this point right here? Is it a liquid or a gas?
Yes.
The answer is yes. It's both. So some of the water has enough energy to change into a gas, but the temperature of the whole won't change until all of the water changes, the liquid changes into a gas. So that's why there's a plateauing there. Now, I hope that some of you have experienced this at home. Have any of you ever cooked macaroni and cheese on the stove, not in the microwave? Good. So if you turn the heat up just enough to get the water to boil, you notice that the water is boiling, so it's at 100 degrees. If I turn the heat all the way to high, now I get the water to really boil rapidly. What's happened to the temperature is I get that water to boil real rapidly as I add so much energy to it. What happens to the temperature? Stays the same. All I'm doing is I'm speeding up the rate of evaporation. Doesn't matter how much heat I add to this, it's just going to hurry the process. So even though it's boiling more rapidly, temperature remains the same until all of that liquid changes into it. All right, so as we go from a solid to a liquid, okay, this is what process is we go from a solid to a liquid. What's that called? Melting. Very good. As we go from a liquid to a gas, that's called evaporation or vaporization. Okay. As we go from a gas to a liquid, condensation is a liquid to a solid. Freezing. What are you saying? What is it when you go from a solid to a gas? And a gas to a solid?
Condemnation. Exhortation. Isolation.
Deposition. Very good.
Deposition.
Okay. So again, and honestly, I think we see more of, we experience more of the gas going to a solid than we do solid going to a gas. And you'll start to experience that here shortly if you drive and you're not allowed to park in the garage. Frost. All right. The next one. The next graph here. This is a pressure versus temperature relationship. This is also a phase change diagram with the pressure temperature. Be sure you know where these states are located, solid, liquid, and gas. Along the edges here are our phase changes. Okay. What is triple point?
It's all three.
All three phases can exist at a particular pressure and temperature. Okay. So it's all three phases can exist at a particular pressure and temperature. And that's huge because pressure does allow us to change solids into gases and other things like that. What is critical point?
Where it explodes.
Can't be neither. Explodes. Edit that out. Critical point is the point. Now we know that we can take a gas and compress it into a, if we push a gas together so much, we can turn it into a liquid. Good. So the critical point is it has so much energy that regardless of how much pressure we exert on the system, we can't get it into a liquid. Okay, so That's what that point there is. That gas, those gas particles have so much energy that no matter how much pressure we exert on it, it will not turn into a liquid.